Hello everyone and welcome back to another edition of Ars Electronica Home Delivery. Today with a short tutorial on designing for 3D printing. 3D printing is a very versatile technology. We use it a lot here in the Ars Electronica Center, mainly for prototyping and replacement parts. For example, JD here, our toy robot, which got a lot of plastic pieces broken already. And the 3D printer can make replacement parts in a matter of minutes or hours. Or for a beloved donkey car, different new chassis models or prototypes for that matter. But today I don't want to talk about making new prototypes. I want to talk about the process of making a replacement part. In this case, I'm trying to do this part of a bed frame for a friend. So what do we need to prepare this one? We need a 3D printer, basic knowledge on how to operate it, and one of the few free programs. In this case, I have decided for Tinkercad, as you see here. So basically you get your caliper gauges or any other kind of measurement device and just start measuring the thing. Tinkercad is very intuitive. You just drag in the basic shapes and adjust the sizing. And then you take these minus shapes and place it wherever you want the holes to be. Like in this case, I've measured this out, and if I group it, it gets cut out of there. Yeah, a few things are to be kept in mind when 3D designing, especially narrowed down to three basic things. The smallest unit is not a millimeter. The smallest unit is, in 90% of the cases, 0.4 millimeters. That's because that's the amount of, that's the width that the 3D printer can print at once. Second one is function over form. Like if we take a look at this thing, do we really need this curvature? Do we really need the small text that is imprinted here? Like narrow it down to what it really has to do in the end. It's not useful to spend hours to get exactly this shape when in the end it just needs to hold up a few planks. And the third thing is measure twice, print once. It's nothing less irritating than waiting for a 2 to 3 hour print just to see that you measured wrong in one crucial place. But let's go on with the process. It's like in the second part of the tutorial. We're gonna take a look at the finer features. Like here, you can see the ridges that get cut out, and those get imprinted. And I've prepared that already because the measuring process is can be pretty lengthy. Yeah, and if we cut that out, we get the basic shape we need. And we export this to an STL or object file, whatever you prefer or whatever your printer manufacturer recommends for your slicer. And go into the slicer. We load the 3D file into here, adjust some parameters like layer height and so on, and let it slice. And here you can see the advantage of thinking in 0.4 millimeter steps. Like this is 5 clean strands of filament and not like 2 on the outside and a bit of squiggly line in the middle. And yeah. Also, if you manage to keep those 0.4 millimeters in thought, you not only end up with a more rigid and durable print, but also the print time gets cut down significantly. It takes 40 minutes in this mode on our printers. And I've prepared a time lapse of this printing. Okay, and here it is. As we can see, it's got the basic similar shape. This thing will most probably perform its function really well. So yeah, what else can you use besides Tinkercad? You could of course just go to a library of 3D files like thingiverse.com. That site suffers a bit from performance issues, but nonetheless it's the most competent and most complete collection of user-generated 3D files. So if you're looking for a replacement part for a common device like backplates of an Xbox controller or certain hinges that broke from headphones or something, you will most likely find it there already reviewed and with recommendations. But which program is there beside Tinkercad? I have listed a few. For example, SketchUp, which is an architecture program from the start, but right now it's a very versatile 3D program that can be handled really intuitively. And the more artistic approach, 3D Slash, you basically have a cube and chisel out all the features that you don't want. It's not that exact, but it's fun to work with. There are also open source solutions that are completely free, like OpenSCAD, which is very technical but also very powerful, and the all-in-one 3D program Blender. There are a few licensed options that allow parametric design, like Rhino or Fusion 360. Those can be free if you're a student or apply for a hobby license, but you have to look into that. Yeah. So besides replacement parts, what else can you do with 3D printing? I've prepared a few examples. Personal protective equipment, like this thing my colleague Thomas made. It's available on prushaprinters.com. It's basically a face shield that snaps into your cap shield. And also one of his other projects, a whole functioning skateboard. Even the wheels are printed with Filaflex. That's a flexible 3D material. Board itself is made from polyethylene. The only metal parts are the screws and the bearings. Yeah, so in conclusion, 3D printing is very versatile. You can do a lot with it. You can fix a lot of things with it. I personally like it a lot for its ecological properties, because instead of ordering a replacement part like this that might get shipped from China or whatever, instead of using the technology and the filament you or a friend might already have at home and saving money. And as I always say, the worst that can happen is that you learn something by doing it. And yeah, so I hope I could have given you a good introduction in 3D printing and design. And yeah, maybe write in the comments if you have any ideas or projects you might have already made with this great technology. Thank you very much.